Lastly, what we're going to do is we're going to create a quadratic based on the solutions. So all we know are the solutions to a particular quadratic, but what is a quadratic that has those two solutions? So we're looking at a solution set that is -5/3 and 1/2. So let's work our way backwards and see where it goes. If that's the solutions, I know that one solution is x equals -5/3 and another solution is x equals 1/2. Well, let's try to work ourselves backwards. We found those solutions by using this, let's set them equal to 0. So I'm going to add 5/3 to this first one. So I have x plus 5/3 equals 0. And then I'm going to subtract 1/2 from both sides. X minus 1/2 equals 0. That has given me my two factors to my original equation. So I have, well, before I get there, I'm going to kind of clean those up and get rid of those fractions. And so I know if I multiply here everything by 3, what do I do to one side as long as I do it to the other? So I have 3x plus 5 equals 0. Again, don't have to do this. I'm just doing it because I like to work with numbers without fractions if I can. And then over here, I'm going to multiply both sides by a 2. As long as whatever I do to one side, I do to the other, it's fair game. So I'll have a 2x minus a 1 equals a 0. And that has given me two factors I can use. 3x plus 5, 2x minus 1. Those are my two factors. Now let's just multiply them out. 3x times a 2x, 6x squared. Outer terms is a -3x. Inner terms is a positive 10x. Outer terms, or last terms, is -5. And clean up the like terms, 6x squared plus a 7x minus a 5. And I can set that guy equal to 0 if I want, or what I have right there. And so 6x squared plus 7x minus 5, that's the quadratic equation that has -5/3 and -1/2, or a positive 1/2, as solutions. Now there's many other quadratics that also have those solutions, but this is one of them. I can multiply this by any non-zero number and get some other quadratics that also work. Let's look at another one too. Let's say I have solutions of -5i and positive 5i. Those are my solutions. So let's kind of work backwards and find out what factors did we see that gave us those solutions. So I know that one is x equals -5i, and another solution of x equals 5i. Well, I'm going to add 5i to both sides in this first one. So it gets me something equal to 0. Over here I'm going to subtract 5i equals to 0. There's no fractions on this one, so I'm not worried about multiplying both sides of the equation by a number to eliminate the fractions. So let's just stick with these guys, and those are my factors. So one factor is x plus 5i, and another factor is x minus 5i. Multiply those out, and I'm kind of seeing there's a difference of 2 squares, but let's multiply it out and see what happens. So I have x squared, first term times first term. Outer terms is a -5xi. Inner terms are a positive 5xi. And outer terms is a -25i squared. Middle terms disappear or cancel each other out. One of the beauties of factors that are differences of 2 squares. So I'm left with an x squared minus a 25i squared. Looks like I can reduce that down a little bit because I squared is a -1. And then -25 times a -1. So x squared plus 25 is the quadratic statement that if I set it to an equation, x squared plus 25 equals 0, it will produce two solutions. And the two solutions it will produce are negative 5i and 5i. So we kind of worked our way backwards. And guys, this is something that will require a little bit of practice and kind of seeing it. And the more that you practice your previous tools leading up to this point, the less practice this will take. If you didn't practice much leading up to these tools in the previous chapters, then here it's going to require a lot more practice.